So we're down to the point at the top of this study here. Scriptural testimony, physical evidence, recent creation. Scriptural testimony, physical evidence from Earth, which testify to a recent creation on the Earth. Methods of age measurement indicate a young Earth. We have an introduction, and then we go all the way down to B. General idea of age measurements. We're going about to point B, which is more specifically on the subject of radioactivity age measurements. There's all kinds of ways of measuring how old things are. Tree trunks, how long it takes for salt to evaporate, water to evaporate, leave more salt, and all kinds of things. Well, here's the first specific radioactivity age measurement by radioactivity. When I ask people how they believe the Earth is old, usually the response that I get involves radiometric dating, Dr. Don Patton says. They claim that scientists have been able to date rocks at millions, billions of years. And radioactive material proves that the Earth is old. That's their claim. Well, let's examine that assumption. Radioactive material is material that is not stable, that decays, that emits particles from a nucleus of the atom. By emitting these alpha and beta particles, it decays to become different elements. And you just have to measure, right? Wrong. Unless you have a laboratory exclusion of all possible variations. Let's see. And we are supposed to be able to tell time with this process, something like you would tell time with an hourglass. Here in a picture, which is being displayed in the video, I wish I could have a modern day YouTube video of this. I could just have you watch it. We find uranium depicted decaying through radium and finally down to lead, which is stable as an hourglass, which would have sand run down to the bottom. You know what? I just did a search for the videos. You can buy these videos from Dr. Don Patton. Just Google it. So you can get the picture. Wonderful resource. Now, if we are told that this is an hourglass, we can look at this and tell how much time has transpired. We would probably estimate 10 to 15 minutes had transpired if we know it took an hour from what's at the top to run to the bottom. But what could go wrong with this kind of a time-telling mechanism? If somebody lifted the top and dumped a lot of extra sand in just before we looked, then obviously our time-telling mechanism would not be accurate. If someone raised the bottom or lowered it so that a good portion of the lead or sand, the sand at the bottom ran out just before we looked, then obviously our conclusion would be wrong. Or if someone would be able to change the opening in the center so that it ran fast sometimes and slow at the other times, then our conclusions would be wrong. And if just before we looked, the conditions that we observe now were the actual beginning conditions, then we would find that no time would have transpired. Even though it works like that, like maybe 10 or 15 minutes have transpired. All of these problems are involved in the radiometric dating systems, which involve the same kind of assumptions. Notice the acknowledgement of that by Henry Fall, one of the leading experts in atomic dating, in his book, Ages of Rocks, Planets, and Stars. He says, two important assumptions are implicit in this equation. First, that we are dealing with a closed system. In other words, nothing leaked in and nothing leaked out. Second, that no atoms of the daughter, that's what's produced at the bottom, in this case, the lead, were present in the system when it formed. These assumptions furnish the most serious limitations on the accumulation clock. Rigorously closed systems probably do not exist in nature. Now that's an amazing statement. Obviously, for this hourglass or this system of radiometric dating to tell time, you'd have to have a system that doesn't leak, that doesn't have material added or deleted. But he says you don't have closed systems in nature. But then he continues saying, but surprisingly, many minerals and rocks satisfy the requirement well enough to be useful for nuclear age determination. The problem is one of judicious geologic Selection. Henry Fall, Ages of Rocks, Planets, and Stars. Well, how do you know if this rock is satisfactory? According to evolutionists, you judiciously select it if the answer comes out to what you assume was to start with. If it comes out wrong in their estimation, then you judiciously unselect it. That's not very judicious at all. It's a little bit bipartisan, you think? Now, not bipartisan. It's partisan. Yeah. Now that may sound very unscientific, and I will certainly agree that it is unscientific. But that is the way it looks in the evolutionist's mind. If it doesn't agree with his conclusions, foregone conclusions, then he says, okay, I reject this. There's some foul play or faultiness. Something went wrong. And that's what happened with a particular rock that this man spoke about a rock that was on a lake bed that was dry. And so obviously there was water around for, if it was hundreds of thousands of years, some water might have been there. And the rock had radium, uranium, U-235, and it had lead in it. And one part of the rock was geared to be thousands of years older than the other side of the rock. But the rock was only a couple of feet long. How do you figure that? And how do you figure if there's water around, uranium is soluble? So it would have leached out of the rock into the water and be gone. So how do you know? See, so if they didn't like one end of the rock, they chose the other. Wow. Then one guy says, that's not fair. Let's take the two ends and average them together. That doesn't make any sense either. Anything to produce a result that would support their point of view regardless of whether it's scientific. So, there are several types of radioactive disintegration that are known to occur in nature. Alpha decay consists of the emission of nuclei of atoms of helium-4 from nuclei of heavy atomic weight. This is the type of decay initiating the uranium and thorium series, whose disintegration results finally in lead and helium with several intermediate elements in the chain. Lots of opportunity, perhaps, for a controlled experiment to measure and determine what the results are. Beta decay consists of the emission from the nucleus of a beta particle of an electron and a neutrino. This is the decay process involved in the formation of strontium-87 from rubidium-87 and of calcium-40 from potassium-40. The third type of decay is the capture of an orbital electron by the nucleus accompanied by the emission of X-rays. The formation of argon-40 from potassium-40 is of this kind. A fourth kind of decay is nuclear fission, by which the nucleus splits into discrete parts. This is the action of the atomic bomb, but it also occurs in nature. The U-235 isotope is subject to fission by free neutrons in the Earth from whatever source. Uranium-238 and thorium-232 undergo a process of spontaneous fission, whereby occasional atoms, under the pressure of high internal proton charge, spontaneously break into two parts. In this process, the main products are the rare gases xenon and krypton, along with neutrons and other particles. Dr. Ball, in his book, which we have cited here, evolutionists maintain there are elements in the rock, such as radioisotopes, which indicate a dearth of millions, and in some instances, billions of years. Well, how old is it? Millions or billions? There is no data scientifically known which can give a rock a uniform age. All of the processes for dating radioisotopic material and alpha particle decay known to science give a variant in age determination when various portions of the same rock are examined. When the alpha particle decay rate is examined, which is the interpretive line of measurement, it is found that it takes uranium, U-238, over 4 billion years to lose half its mass. The problem with that is, suppose you take uranium and water hits it, it leaches it out. So now it's going to make that rock look pretty old, because half the rock leached its uranium into the waters, like that riverbed rock that we found, that was found. The line of reasoning goes that it had to have been around for at least 4.5 billion years to have lost that much mass. This is not necessarily so. It really shows that U-238 was designed to be around for billions of years, and it was designed to be here for a useful purpose. It is obvious from the work of geophysicists that these isotopes were at one time inside the Earth. They were expunged or thrown out to the surface of the Earth, perhaps by a volcano or earthquake. What this demonstrates is that the interior of the Earth at some time in the past was a perfectly balanced thermonuclear heater. If these isotopic elements are so arranged with moderating elements adjacent to them, the result is simply a controlled nuclear reactor. God designed the interior of the Earth as such for the benefit of man. Remember, you're tired. It felt good by not exercising. Feeling good. It's like eating certain foods that make you feel good for a while, and then not. I don't know what carpenters are going to sound like. Well, we just cross the bridge when we come to it. Yeah, you got through those buildings a block away. Push it too hard. Oh, you ate some breakfast. I bought his videos, and I'm just transcribing them. Wow.